Hello. Hello and welcome to this video. In this video, we are going to discuss a very interesting topic, that is Podman versus Docker. Now, almost all of developers know about Docker, but relatively very small number of people know about Podman. So Podman is something which is a Docker replacement. It is from Red Hat, and it is command by command compatible with the Docker CLI. So we will discuss three things. One is architecture, second is performance, and third is security. So the question is, why should we compare Podman and Docker? The reason is, in fact, the idea is that why we should not use Docker. That is the main idea behind this presentation. This comparison basically will establish how Podman is superior to Docker. So containers are not only are now core infrastructure primitive, not just dev tools. So it's not only about developers. Okay. Security, compliance, and multi-user systems matter as much as developer user experience. We will see how Podman beats Docker in terms of security, compliance, and multi-user systems. Both Docker and Podman share OCI foundations but diverge philosophically. So now we look at high-level architecture. Docker, as most of you would know, is centralized, daemon-driven, because we have a Docker-D running. Okay, it has a long-running privileged service, Docker-D. Privileged means you have to run it as user. It has strong abstraction from the host OS. Now, Podman is daemonless, process-oriented architecture. There is nothing like Docker-D. Containers are regular child processes. So when you run Podman, it just forks and it embraces the host OS and systemd. Now we look Docker component stack. So it has a CLI, it has Dockerd, it has containerd, it has runc. Okay. So Dockerd is the central daemon which manages all container state. Containerd is responsible for container lifecycle, and runc is the runtime for executing the containers. CLI is what most of you would know because that's what you use in day-to-day business. Now, how Docker works is CLI sends REST request over Unix socket or TCP. Dockerd then performs authorization and orchestration for the containers. Containerd will supervise the container process, and runc will perform clone, set namespace, cgroups, execue, and so on. Now, if you look at the consequences of the daemon model of Docker, what happens is you have a Dockerd and containerd. So if those fail or get hijacked or get hacked, then you have single point of failure. It always requires root privilege or root equivalent. Podman also requires root privilege, but that is for different regions. In some cases, you need root privilege for Podman as well. The case which would be most common is if you want to bind to ports less than 1024, then you would need root or root equivalent elevated privilege. There is clear separation between user intent and kernel execution for Docker. The daemon model enables rich ecosystem and remote management. Now, if you look at Podman, it has Podman CLI, which directly manages container. There is nothing like Dockerd or containerd. You have conmon for monitoring the container input output. OCI runtime, runc or crun, either will work with this. Systemd, which is the parent process of all the processes on Linux, which is used for lifecycle supervision. Now, whenever you do Podman run, it will fork a process tree. Okay. If you don't know fork, then what fork is that when a process calls fork, then a child process is created. Okay. And then you can call exec to replace the code of the new process with some other program. So for example, the most common example is, suppose you're on terminal and you call ls. So what the shell does is it first forks the, for example, bash shell or ZSH or CSH, doesn't matter which shell it is. It first creates a bash shell process, then it execs ls. Exec means the code segment and data segment, those are copied from ls to that of bash process, child process. So now the bash process becomes the ls process, and then it continues the execution. Podman does not have any global state stored in a privileged daemon because it is daemonless. There are no daemons where you need to store the global state. Container lifecycle tied to user session or systemd unit. So you can make a service of systemd. Otherwise, your container will be running as long as you have user session. Containers are visible as normal processes. That is, PS and top will show the containers. Pods, that is Podman's pod. Native support for Kubernetes style pods. Shared namespaces across containers in a pod in Podman. Easier conceptual mapping to Kubernetes. Docker requires Compose or Kubernetes to emulate this. So suppose you want to run, let's say, 3 or 4 services inside in a Docker network, then all of them have to be put inside the same network, and you have to create a network group in Docker Compose file for that. Docker itself cannot do that. But Podman can share the namespace across containers in a pod. Now we look at the performance difference. So performance is not from the containers themselves because both have same kernel features. The difference between Podman and Docker comes from the orchestration and supervision. That is daemon scheduling versus direct process execution. Dockerd and Containerd will consume memory and CPU continuously. For Docker, extra IPC hops for lifecycle operation. Docker is optimized for long-lived services. It has strong image caching and layer reuse. If you compare the same thing with Podman, it has zero idle overhead because there is no Dockerd daemon or Podman daemon. It has faster startup for short-lived containers. crun often outperforms runc due to C implementation. It is ideal for CI/CD and batch workloads. Now we come to probably the most important part, that is the security. So containers are not the virtual machines, kernel is shared, that is one thing. The second thing is attack surface is dominated by control plane design. Here we are talking about the control panel of Kubernetes. However, root access amplification is the key risk in Docker. Dockerd typically runs as root. Access to Docker socket means you have root access. Rootless Docker exists but is less mature and people generally don't do that. Hardening required for multi-tenant systems. Now, when I said that you need root privilege to bind to ports below 1024, however, it is possible that after binding to the port, you can drop the root privilege. For example, Postfix does it. Postfix binds to port 25. To start the mail server, or that is the Postfix server, you start it as root, but then Postfix drops that privilege and runs as a normal user. Now, Podman is rootless by default and uses user namespaces extensively. There is no privilege daemon to compromise, and it has strong SE Linux integration, for example, with RHEL or Fedora. Docker is large, attack surface is large, always on, network accessible daemon. Podman is short-lived CLI processor, reduced blast radius for Podman, and easier auditing with standard and Linux tools for Podman. Now, if we look at systemd integration of Podman. Podman can generate native systemd units. Containers behave like regular services. Docker requires additional wrappers. The ecosystem, when we talk about, then definitely Docker will have larger ecosystem because it is older of the two. There is Docker desktop and there is Compose, Docker Compose. Podman is CLI compatible with Docker and it is Kubernetes aligned. There is also Podman Compose is there. So I forgot to write that. Podman Compose is there. OpenShift internally uses Podman concepts. Now we will summarize this. So key takeaways you can read for yourself. I will go with the final verdict that where you should use what. So use Docker for developer-centric workflows and tooling, and use Podman for servers, CI, and security-sensitive environments. So that is the final conclusion I will draw from this presentation. And I hope that you understand now, or if you have not known about Podman, then you will at least give it a try and see for yourself how Podman is better than Docker. If you are not convinced by this video, then I would implore you to perform your own research. You do some search on internet, ask AI which one of these is better, and I'm sure that it will turn out in your case that Podman is superior to Docker. So thanks a lot for watching the video. And do not forget to like the video, share it on social media, and subscribe to the channel. I will see you later in next video when I will record, that is tomorrow probably. So thanks a lot for watching. Enjoy.